Hi, I hope everyone is doing well. Here's some notes for lesson 12, and this is about solving quadratics. Before we launch into it, I just want to show you a little whiteboard here. So there are 4 main ways to solve a quadratic, and this does not include graphing because that's a little bit of a different way. That's more, it's a graphing will show us the solution or the solutions, or that there is no real solution. So it's more of a visual way to solve a quadratic, but it's not, I would say, the most efficient way to do it. So here are the big 4 that you're going to hear about for the rest of this unit. So factoring is going to be kind of in some ways it's going to be a go-to, but in order for you to use factoring to solve quadratics, it has to be factorable. Things to look for if you're going to identify if something is factorable, you always want to look for the greatest common factor. If there are 2 square numbers that you're subtracting, that's a difference of squares, and there'll be some examples I show in a minute. If it's a basic trinomial or a trinomial that has an a value that is greater than 1, where's my dry erase marker? Oh, great. It's not here. Okay, that's okay. So it's the basic trinomial or a trinomial that has an a value that is greater than 1 or a greater than 1. And that's when you're going to do the slide and divide, right? You can factor it that way. So the basic trinomial would be that product sum game. So if you try the product sum game, then that's a good way to go about it. But if you try to do the product sum game and it doesn't work, then maybe it's not factorable. So you might want to try a different method. Anyway, once you factor it in all these different ways you can factor, then you want to set each side to 0. You set the whole equation to 0 and then each side to 0, or each factor to 0, and then solve. So that's a great way to start, depending on it's factorable or not. This does take practice to try to decide which method to use. Over here, square roots. If there's no middle term, so no bx term, then that could be a sign that you can find the square roots. You're going to move the c to the other side of the equal sign. You're going to divide by a, and you're going to try to take the square root. So basically, if you look at numbers that they're square numbers on both sides of the equation, that's a telltale sign that you can find the square roots of both sides. So if you have something like, I don't know, x squared, for example, equals 36. Well, I think a lot of you sitting at home would be like, oh yeah, well, x is 6, right? Well, can you take the square root of both? Yes. So that would be a really great x equals, right? Positive or negative 6. So these can get a little more complicated, right? If you have 4x squared and then you have some other square number, then that would work too. Completing the square, that is one of our goals here, is to kind of manipulate an equation, a trinomial. What you're trying to create here is to make a perfect trinomial on the left side. That takes a little more effort. And there are visual ways to do this I can teach you later, but this involves a little more work. You're going to move a c to the side. That's when you take a half of that b term, you square it, you add it to both sides because you're trying to create a perfect square trinomial. And then you're going to factor it and then take the square root of both sides. So that's a lot of work, but you have to decide, when to do this or not. And then over here, last but not least, you have the quadratic formula. And again, that is an easy one I shouldn't say easy. That is one that is, it will work each time. So it can take maybe the guessing out, right? It's just a plug and play. You you know, you're going to use this formula that you should practice and try to get really familiar with, and plug in the values. You can always tell, like, whatever is underneath the square root sign is called the discriminant. And we did that quick mini lesson on if you can quickly tell if a quadratic has a solution, has two solutions, maybe it doesn't have any real solutions, by just determining what the sign or the result of what's under this radical sign is. Okay, that is a very quick overview, but these are the 4 real ways to solve a quadratic, which you will, it'll come back to you for any algebra class you're in. This should be something that you memorize, okay? So if I go to today's lesson, and we're going to compare these, choosing the best method, okay? So when you factor, what I said before is you want to choose factoring when the equation is factorable. And what does it mean by factorable? Well, factorable means, right, that you can break it up into separate factors kind of easily. And I will, if it does help you, I'm going to write a little note here. So factoring, don't remember, that's funny. Whatever you do, don't remember. Factoring, you always want to look for the greatest common factor. It's always your first step. Second step is I do, if it's a binomial, if it's a difference of squares, like x squared minus 9, right? That's a difference of squares. That's a moderately straightforward way to factor. You can have a basic trinomial, right? X squared, plus 2x, right? Plus 1, something like that. And then you can do it, I'll just call it a basic try. And that's when I would do the product sum game. And the other thing you're going to find a lot is if you have an a value, right? If you have an a value that's greater than 1, that's when you're going to do the slide and divide, okay? Okay, the square roots is, the tip for using square roots is when you have no middle term. Oh my goodness. Middle term, and that would be that bx, okay? Completing the square, well, here's the big tip for completing the square. When a equals 1, so it's kind of like a basic trinomial, and we just learned something new, and b is an even number. Because I don't know if you remember that if you, when you're completing the square, you want to take half of b. And the best way to take half of b is, the easiest way is if it's an even number. You just split it in half without any decimals or fractions. Okay. Quadratic formula is basically all other cases, or every other, or if in doubt. But it does take, sometimes it takes a longer period of time. Okay. So when is it factorable? We could write this again now, right? Other cases for when it's factorable is if the equation is factorable. If it's, this is another way to tell if it's factorable. If it's discriminant, and that would be that d discriminant equals b squared minus 4ac. Is a perfect square number. So there are, again, lots of different tips and tools. It just takes a lot of practice. Okay, so let's go for the examples now. So what it's asking here is use use your brain, use everything you know to choose a method and solve each equation below. You can only use each method once. So we have these 4, and I have to decide how I'm going to solve these. Is there a right answer necessarily for like which method I use? I don't think so, but maybe there's a better answer. So let's see. If I look down this list quickly, I am going to point out some things that I notice. The first thing that jumps out at me here is that 9x squared, this is a square number, right? Oh, and so is 4. That's a square number. So these are difference of squares. Okay. Could I move the 4 on this side? And if I have 2 square numbers on both sides, I could just use square roots. So maybe I start with that. Okay. So I'm going to solve this the square root way. Okay. So 9x squared equals, well, I'm going to add 4 because I want to get them on both sides of the equation, plus 4. Okay. So 9x squared equals 4. Now what we do is we are going to try to isolate our x. So we're going to divide both sides by 9. 9 divided by 9, well, that becomes 1. So now I have x squared equals 4 over 9. And I am not going to divide this out. I'm not looking to get a decimal or anything. I'm going to keep it in this form. And I like this form because I see I have a square number on top and a square number on the bottom. So now I'm going to take the square root of both. What I do to the left, I have to do to the right. So the square root of x squared is x, and the square root of 4 over 9, well, the square root of 4 is 2, and the square root of 9 is 3, okay? Remember, I just took the square roots of both, so the answers are the positive and the negative 2/3. So I can write that as a set equals negative 2/3 and positive 2/3. Okay, let's see. What else do we notice here? Well, let's look back at the completing the square rule. Up here it says completing the square is if a is 1. So let's look maybe at the rest, and b is even. Okay, a is 1, b is even. So let's see. A is 1. Well, that works for this. A is 1, and b term is even. Okay, we can do that. Let's look here. Oh, a is not 1. Oh, and notice here a is 1, but the b term is not even. So I think that we're going to have to stick to completing the square for number 1. Okay, so when we complete the square, here we go. So first of all, I want to move my c. So let me see here. I want to go ahead and subtract 7 from both sides because I want my a and b term here. So I'm going to rewrite this x squared minus 6x equals 66. So now I have it in the right form. I have my a and I have my b and I have my c on the right. A lot of times you're going to move your constant on the right when you're factoring. Not all the time. And when we're completing the square, so our first step, completing the square, was going to be move our c to the right. Our second step for completing the square is I'm going to take half of b and I'm going to square it. And I'm going to add it. Okay. So here we go. So I'm going to take half, because this is an even number. I'm going to take half of it, which is negative 3 squared. I'm going to square it, and I get 9. And then I'm going to rewrite this. X squared minus 6x plus 9, because I just added that. I'm going to add it to the other side. Equals 66 plus 9. I'm adding it over here. Okay, so I got my first step, second step, and this is when I complete the square. Okay, my third step is going to be to then take the square root of both. Actually, well, I have to factor it next. So let's go ahead and factor it. I'm going to write that. Factor the trie. And I'm going to do the product sum game here. So I'll do it right here. So right here, I just manufactured a perfect square number. So I'm going to get multiply to 9 and combine to -6. And I know they're both going to be negative numbers, and if it's a perfect square, it's going to be the same. So I should have -3 and -3. Okay, so next step, I'm going to rewrite it. X minus 3, X minus 3. That equals the same thing. Equals, I'm going to add those two, 66 plus 9 is 75. So now I have, I've factored the trinomial. I combine these terms. Now I'm going to rewrite this as a kind of a square number here, equals 75. Okay, so then my fourth step here is going to be to take the square root of both sides. So 1, 2. So now this becomes x minus 3. And then I have the square root of 75. Well, let's rewrite 75 as 25 times 3, okay? If I take the square root of 25, I'm going to take that out of here. That is going to be 5, but I cannot take the square root of 3, so it has to remain. So I basically found the factors of 75 over here and found that I have a perfect square that I can work with, and then I have the remaining of 3 that I can't work with. I want to make sure I add my positive and negative, okay? And then I need to add my 3 to both sides because I want to isolate my x. So x now equals 3 plus or minus 5 square root 3. And that's my answer. So the fifth step here, you took the square root of both, and then you isolated your x. Okay. Now, am I still recording? Yes. Okay. So I have completing the square. I have square roots. Now, let's go here. For number 3 and number 4, well, let's see. I still haven't done the factoring one. So would I rather try to factor this or this? I think I'd rather factor this because it's a basic trinomial, but so let's see if we can factor it. If it's a basic trinomial, I want to try to see if I can get to 14 and 9. And, oh, I know, 2 and 7. If I use 2 and 7 positive, I'm going to get 9. So that's pretty easy to factor. So let's do it this way. So I'm going to rewrite this basic trinomial in its factored form. And I have x plus 7. And I have x plus 2. And I'm going to set it all to 0. Okay, so now I'm going to draw a line. And I'm going to set each side to 0. So x plus 7 equals 0. X plus 2 equals 0. And some of you may notice that you already know, well, I'm going to subtract 7, right? So x is going to be the opposite sign of this factor. Subtract, subtract, and the opposite sign of this factor. So x is equal to -7, comma, -2, the set. Okay. So I think this one we're just going to go ahead and do the quadratic formula. And I will write the quadratic formula again over here. Okay, so, and again, this is a really good one to memorize. So the quadratic formula is x equals -b plus minus, here's the discriminant, b squared minus 4ac all over 2a. Okay. So now let's just plug and play for number 3. Okay, so A is going to be, and again, I like to list out my numbers first. A is 2, but Meanwhile, I need to get this into standard form, right? So let's write that note, standard form. So I actually need to move my 3 over to the left because the whole thing has to be set to 0. So I'm going to subtract 3 from both sides. So before I actually identify each a, b, and c, it'll be easier if I rewrite it. So 2x squared, I'm going to hold on to my 8x. I didn't switch that at all. But now I'm subtracting 3. So 10 minus 3 is 7, and I'm going to set it all to 0. Now I can identify my terms. B is 8 and C is 7. Okay, and now we're just going to plug all that in. So x equals negative b, so that's negative 8 plus minus b squared. So I have 8 squared minus 4, and then I need an a, which is 2, and I need a c, which is 7, all over 2 times 2, because that's my a. Next line, negative 8 plus minus square root of the discriminant here. So I have 8 squared is 64. And then I'm going to combine all these. I have, looks like I have 8 times 7. Yep, so it's going to be negative. So negative 56 and all over 4. Okay, next line. X equals negative 8 plus or minus. And then if I subtract these, so I still have the radical sign, square root sign, 64 minus 56, which is 8. Okay, all over 4. Now I can think about 8. 8 is one I can actually simplify. 8 also equals 4 times 2. Can I get the square root of 4? I can. So I could rewrite the square root of 8 as 2 root 2. So x equals negative 8 plus or minus this whole thing, which again is, I could simplify the square root of 8 as 2 root 2. Okay? All over 4. Okay. Now I can even simplify this because I have 8 divided by 4. It's kind of like thinking like this is fractions. So negative 8 divided by 4, I could simplify that as negative 4. I'm splitting both in half over 2 plus or minus, and then I had 2 over 4 right over here. So I could simplify that as 1 over 2 square root 2. Do I need this 1 here? No. So this is just to show you this is just 1 times anything is just itself, okay? So you do not have to include that one, but it might be helpful for now to include it. Whew, this is a lot. Okay. I'm not going to do all of these because I'm already up to 23 minutes. So let's see. You can use whatever method you want to use on all of these. So if I look at, let's see, number 5, I could, if you think about what you might do here, you can always pause, right? And then think about how you might attack this one. But I'm actually going to do completing the square for number 5. I'm going to write CS to myself, complete the square. Okay, because it's already in that right form, which is ax squared plus bx equals c. It's already in that form, so I could just go for it. Okay, so to complete the square, first of all, I'm going to divide. Oh, and remember, I have a is 1 and b is even. So this blends itself nicely. So I'm going to split my b term. Okay. And then I'm going to add it. So x squared minus 2x plus 1, because remember I'm trying to create a perfect square trinomial, and then 4 plus 1 over here, I have a trinomial that I need to factor now. So my basic trinomial, I'm going to multiply to 1, and I'm going to combine to -2. Well, I know it's just going to be 1 and 1. And they're both going to be negative. Okay, so I'm going to rewrite this in the product of its two binomials, and that is a square. So then I'm going to rewrite this as a squared binomial equals 5. And now I'm going to take the square root on the left side. I get rid of all the signs here. So now it's just x minus 1 equals the square root of 5. I want to isolate my x. I'm going to add 1. So x is going to equal positive or negative. Don't forget that. So I'm going to put that constant first, 1 plus or minus the square root of 5. And that is your answer. Okay, now let's look at number 7. So number 7, if I analyze this, I'm not going to complete the square. Could I factor it? I could try to factor it. I don't see like a difference of two numbers, so I'm going to factor this. So I'm going to first see if there's a greatest common factor. And I look at these, immediately think 5. So I'm going to factor out the 5. I'm going to put it out aside, and I'm going to divide. And I got a step ahead of myself. So when I divide this out, I have 5x squared over 5. So I'm going to end up with x squared minus 3x. And then 50 minus 5 is 10, set to 0. So I always have to set to 0. Okay, I just did that. Now I have to factor, continue to factor. So I have another move I can make, and that is that I can break this basic trinomial. So I'm going to do the product sum game. It's a -10 and -3. Well, let's see. I like 5 and 2. 5 times 2 is 10. If I combine these with a -5, that'll work. Okay, so now I have 5. I have x minus 5 and x plus 2 equals 0. Factor them all. Okay, 5 is not equal to 0, so that doesn't even count. X minus 5 equals 0, so x is going to equal 5. X plus 2 equals 0. X equals -2. So your answer is x equals the set of -2, 5. Okay. Now I have number 9. Let's see, I have a negative. What am I noticing? I have a negative a. I have an even a. I mean, an even b term. Let's see. But I want to get rid of this negative sign. So let's just multiply everything by -1. Or you could even say divide by -1. So I'm going to distribute this negative sign. So if I do that, let's see. I'm going to just change the sign. Because again, if I multiply this whole thing by -1 or +1, I simply get rid of that negative sign. So I'm going to rewrite this. Okay. Okay, and then I can go ahead and can I factor this out? So, sorry. Okay, so now I can do the product sum game, or can I? Let's see. This is a little interesting actually here. I'm going to try it a different way. If I get my product to 63 and I'm going to combine to negative 16. Let's see. 9 and 7. Let's see. Can I do a 9 and 7 combined to 16? Yeah, 9 times 7 is 63. And then if they're both negative, I get negative 16. Okay, that'll work. So then I can rewrite this. X minus 9 and x minus 7 set to 0. And then set both sides to 0. So x minus 9 equals 0. So x is 9. X minus 7 equals 0. And x is equal to 7. If you look at the answer key, by the way, they made it much more complicated, or I did, or anyway. So then here are the two answers. So really, this is just a basic trinomial that I had to get rid of the negative sign. Okay, last but not least is 11. Okay, so what I see about 11 here is, I could... What am I looking for here? What's a good way to do it? Well, I see that the A is greater than 1. Let's see. And is the B even? Oh, the B is even. So maybe I could I complete the square or do square roots? Is there a B? Oh, there's no X term. Great, there's no BX term. So I can, if there's no BX term, I'm going to do the square roots. Okay, so let's try it. So when I'm doing the square roots, then I want to get this in the right form. So first of all, I want the C value to be on the other side. I'm going to add 16. And I'm going to get, to both sides, I'm going to get 48. Okay, so now I have 6x squared equals 48. Okay, so now I want to get the x alone. So I want to divide by my 6. So now I am getting rid of my 6. 48 divided by 6 is 8. So now I have x squared equals 8. So right now I'm just isolating the x. I'm just trying to solve for x. Well, x equals the positive or negative square root of 8. Now this is not in simplest form because I can break apart 8 into the square root of 4 times the square root of 2. Okay, so I could rewrite this as 2 root 2. And that's one that you'll probably start to memorize, that 8, the square root of 8 is always 2 root 2. And don't forget, we're going to have positive and negatives. So the answer to this is going to be x equals positive or negative 2 root 2. And I think we're done for the day. But this takes a lot of practice. Good luck. Reach out if you have any questions.